I can rewrite this one, and this is here complete, but just for a note, we can write this one also in the form we having here x, our x is xy, and then we are having here this is equal to, we are having here 3c1 and c1, and get here e to power minus 2t, and plus we are having here c2, and we can write here this is equal to minus c2 plus c2 e to power 2t. So we rewrite this one. We can have here this xy is equal to, we can write this one as minus 3c1 e to power minus 2t minus c2 e to power 2t, get here c1 e to power minus 2t plus c2 e to power 2t. Now we can write here the solution of our equation, solution in terms of x and y. My x is equal to 3c1 e to power minus 2t plus c2 minus c2 e to power 2t, and my y is equal to c1 e to power minus 2t plus c2 e to power 2t. So that's how we can write the solution of our problem. So this is just the usual as we are doing before, and here we write in a matrix form in terms of eigenvalue and eigenvector. So this is the idea. We're going to take one more example, and we apply the eigenvalue eigenvector method to solve the system equation. Now I'm going to take the system equation with three variables. It's a homogeneous system. We have dx by dt is equal to x plus 4z, dy by dt is equal to 2z, and dz by dt is equal to 3x plus y minus 3z. Now I write this in the form of the equation that x dash is equal to a dz. I keep the derivative on the left hand side and all the values on the right hand side. Already they are. So I just write in matrix form so that I have the coefficient. I have the coefficient 1 for x, 0 for y, 4 for z, and then from second equation 0 for x, 2 for y, and 0 for z. In third equation I have 3, 1 and minus 3. This is the coefficient of the x, y, z, and then we have the unknowns x, y, z here. I write the matrix form, this x dash is equal to ax. Now to write my method, that's my eigenvalue eigenvector method, I take here the solution of this one is equal to x is equal to k times e to power lambda t, where my k, lambda is the eigenvalue, k is an eigenvector, and a is an operator. So here I am interested in this system to find the eigenvalues and a vector. I substitute this in my equation, x dash is equal to ax, and simplify. I get here ak is equal to lambda k. I take lambda k on the left hand side, I get a minus lambda I is equal to k, because lambda is a scalar. So we take the I as a matrix of the same size. So this becomes matrix form, and then we can write to add, and because we can add and subtract only two matrices of the same size. So we have to make the matrix of the same size. So if this having non-trivial solution, we are interested in non-trivial solution only when this coefficient, the determinant of this one is equal to 0. When I take determinant of this equal to 0, that gives me the values of lambda, and these values of lambda will be my eigenvalues. Then by using my eigenvalues, I will find my eigenvector. We go step by step. So here I write here this is equal to a. My a is 1, 0, 4, 2, 0, 0, and 3 minus 1. And here put the value of, we have lambda I, this lambda 0, 0, 0, lambda 0, 0, 0, lambda. And then I am having here taking this, combine these two together. I get the matrix equation, determinantal equation 1 minus lambda 0, 4, 0, 2 minus lambda 0, 3, 1 minus 3 minus lambda. So I open this one and I get to find the values of lambda. I open from the first, from this from a to 2. This is the second row. The second row is 0, multiply the coefficient is 0, then 2 minus lambda, multiply the cofactor, and then 0 multiply the cofactor, that will be 0. So only one cofactor is 2 minus lambda. Removing this row, this is removing this row, this will become, we get 1 minus lambda, 0, 4 minus 3 minus lambda. So I just simplify this one. I get here the equation. I can keep this 2 minus lambda out and simplify this one. We get lambda square plus 2 lambda minus 15. Factorize this one. I'll get here 2 minus lambda, lambda plus 5 and lambda minus 3 equal to 0. Now I write the values of lambda. Lambda is equal to 2, lambda is equal to 3, and lambda is equal to minus 5. These are the three eigenvalues we get. Now to each eigenvalue, I will interesting to find the eigenvectors. To get the eigenvector, I use this equation. That's the equation I have developed here. This is my equation which I am going to use to find the eigenvector. I have a, I have lambda, and from there we try to get the value of k from putting lambda in equation 1. A is already given. So we get here, this is value of lambda is equal to 2. So I get here 2, 0, 0, 0, 2, 0, and 0, 0, 2, and this my k is k1, k2, 3, the column vector. Now I rewrite this one. I get three equations here we get here these two equations. I just simplify this, we get two equations, minus 1 lambda, minus 1 k plus 4 k3, then 3 k1 plus k2. We solve these two equations to get the values of k1, k2, k3. We have three unknowns and we have two equations having infinite number of solutions. We simplify it and we'll get here this matrix equation, and we want to find the value of k1, k2 and k3. We rewrite in the equation form. We can see it here. We have two equations. We're having three unknowns. So this means one unknown will be free. We have a free variable. Mostly we take this any scalar. We say t. Mostly we take t. T is any real number. I just want to put it equal to 1. I put it equal to 1 and then I solve this one. I put here k3 equal to 1. Then my k1 is equal to 4, k3, put k equal to 1, get here k1 equal to 4, k3 is equal to 1. Substituting the last equation, I get the value of k2 is equal to 7. So I get the values of the solution of this system of equation, homogeneous equation, when lambda is equal to, the value is equal to 2. We get here this equal to k1 is equal to 4, k2 is equal to minus 7, and k3 is equal to 1. So my k is equal to k1, k2, k3 is 4 minus 7 and 1. So I can write my x1. That's my x1. As I told you before that we are having here the value of x is equal to k e to power lambda t. I have lambda, I have here k. So as I mentioned here, I get here x1. x1 is equal to k1 e to power lambda 1. So I want to find k1, I get lambda 1, I substitute here. So I get here this equal to x1 is equal to 4 minus 7 by 1 e to power 2t is my equation 4. Now I take the second value of lambda. I have three values of lambda. One lambda I have taken lambda 1 equal to 2, lambda 2 equal to 3. I take lambda 2 equal to 3, substitute in my equation here. In this equation I have a, I have lambda, I have I is there. I want to find k. This k is k1, k2, 3. Again I simplify this one. I get the matrix equation form of this system of equation. I rewrite again. I get here this three equations. I take here the value, well the second equation that gives me the value of k2 equal to 0. When k2 is equal to 0, I'll get here the value of k2, putting k2 equal to 0, I get the equation. From the last equation, I get here the value of first equation 2k1 is equal to 4k3 and k1 is equal to 2k3. And here we say that we are having the second equation, when I put here t equal to 0, the same equation which is being repeated. I get here k, from the last equation also k minus is equal to k2, 3. So in practically we are having two equations only, and here only one equation is left because k2 was 0. So I again substitute some value of lambda, free variable. I take value of k3. I can take k3, I can take k1. We can take any one of the unknown. So take k3 equal to 1. Give me the value of k1, that's equal to 2. So values when lambda equal to 3, I get the value of k1 is equal to 2, k2 equal to 0, and k3 equal to 1. So that gives me the value of k2. That's the second related to lambda 2, and here lambda 2 was equal to 3. So get is 2, 1, 0. So again I substitute here in my equation and I get here the solution x2 is equal to k2 e to power lambda 2t. My k2 is 201, my lambda is 3, lambda 2 is 3, so get here 201 e to power 3. This is my x2. Now my last value, which is lambda 3, say it's lambda 3 is equal to minus 5. Again I substitute here lambda 3 equal to minus 5, minus become plus, and I get here simplifying this one and we get the matrix equation and rewriting that one. I'll get here the equation for the system of equations. Again here we can see from this equation, second equation, we get the value of k equal to 0, and from the first equation we get here this one. Then we will get the value of k from here. k1 is equal to this equation, and we are having here k2 is equal to 0. We put k2 equal to 0, then we get here k1 equal to k3 from the first equation, and we get here the value of substituting here. Again we let the value of k3 equal to 3, taking value of 3 k here is k3, not k2, k3 equal to 3, then 3 is 3 cancel, and we get k1 equal to 2. So that gives me the value of k1 equal to 2, k2 equal to 0, and k3 equal to 3 again, and I substitute this one in the last equation. Then this is going to be satisfied. If it's going to satisfy the last equation, mean the value is correct. If it's not going to satisfy the last equation, then we suppose k3 again. Or we can take here this equation, substituting k2 equal to 0. We can just simply solve this one, and when we solve, we get the value of k1 equal to 2 and k3 equal to 3. We can do like that one also. So here I get the value of k1, k2 and k3. So my k3 is equal to k1, k2, k3 minus 2, 0 and 3. Now I can put the value of this k3 and lambda 3 in my equation and get the value of x3 is equal to minus 203 e to power minus 5t. This is my equation 4. Now I can write my general solution. This x is equal to, here I'll get my x is equal to c1 x1 plus c2 x2 plus c3 x3. I have x1, I have x2, I have x3. Substitute here. This is my general solution. If you want to write x1, y1, z1, just again change the matrix form to the equation form. You can write the value of x, you can write the value of y, and you can write the value of z. Thank you very much.